Physics, Images, and Optics. So for this, we have an example of a converging mirror with a radius of curvature of 25 centimeters. Objects are placed at 50 centimeters, 20 centimeters, and 8 centimeters from the mirror. Find the following information. A. Where is the image formed? B. Is the image real or virtual? C. Is the image erect or inverted? And D. Is the image magnified or reduced? So out of this, we can pull a couple of pieces of information. So for our knowns, we have the radius of curvature at 25 centimeters. We know the focal length. Focal length is always just for a converging mirror. It's 25, or it's going to be your radius divided by 2. So 12.5 centimeters. And then we know the initial distances, so D naughts, are 50 centimeters, 20 centimeters, and 8 centimeters for 3 different cases. And then our unknowns are the image distances, the magnifications, and then some other information on the images. So, as always with physics problems, best way to start out is to draw yourself a picture. So over here we have the converging mirror, and then we have the focal point, F, and then we have the radius of curvature, which you can specify as a point, but it's more like a, I guess, just kind of a location. It's a theoretical place, but not like an actual point. And then out here, for the first case, we have 50 centimeters, which is out past the radius of curvature. And then we have the 20 centimeter one, which is between the focal point and the radius of curvature. And then we have the case 3, which is between the mirror and the focal point. So, for all of these problems, you're going to use basically the same formula again and again and again. That formula is going to be 1 over F equals 1 over di plus 1 over d object, so do. So with that, you've got some values that you can go ahead and plug into that. So for the first case, we know that we have 1 over F is going to be 1 over 12.5 is equal to 1 over di, which we don't know, plus 1 over d object, which is going to be 50 centimeters. Solving for di is equal to right about 16.7 centimeters. So the other thing to note about this is it's a positive number that you've gotten out. So positive means real. So 16.7 centimeters and real. The next thing we need to do is use the magnification equation. Magnification is equal to negative di divided by do. So for that we can go ahead and plug in di, so that's negative 16.7 divided by do, which is 50 centimeters. And then when you go ahead and plug in and reduce these things, you get a magnification of negative 0.334 thereabouts. is equal to your magnification. So, two things to note from the magnification. One, it's less than 1. So magnification less than 1, or the absolute value of the magnification less than 1 means that your image is reduced. So it's smaller. And then the negative means image is inverted. So basically, this problem is just applying these two formulas again and again. These two. Okay. So reduced, inverted. Alright, so problem number 2. You have same formula, so we can go and just plug in numbers. 1 over 12.5 is equal to 1 over di plus 1 over our next case, which is 20 centimeters. So solving for di is equal to 33.3 centimeters. Note that it is positive, so positive means that it is a real image. So magnification is equal to minus your di, so 33.3 centimeters divided by your d object, which is 20 centimeters. When you reduce that down, you get magnification is equal to negative 1.67. So note that this value is the absolute value of the magnitude is greater than 1, which means that the image is magnified. And then there is a negative sign in front of it, which means that it is inverted. So that's it for that one. And then part 3, same formulas again. 12.5 centimeters is equal to 1 over d image plus 1 over our last one is 8 centimeters. Solving for di is equal to, interestingly, negative 22.2 centimeters. With this negative in here, that means that the image is virtual. Then with magnification is equal to minus your image, so minus 22.2. So yeah, minus 22.2 divided by your distance of the object, which is 8 centimeters. And then when you reduce that, you will end up with magnification is equal to 2.78. Notice that it is positive, so your image is going to be erect, or right side up, and then it is also going to be magnified, so it's going to be bigger.